73% of reported encounters with unknown animals in North American wilderness during the 20th century were logged by people who were working alone. The story that follows is a life story of the practice that grew around those reports the strange. Stubborn craft of hunting cryptids for a living, from its quiet birth in rumor and field biology to the uneasy legacy it left behind, long before anyone tried to earn money from the pursuit of unknown animals, there was a problem of evidence. Forests were large, mountains were empty, and human knowledge of wildlife was incomplete in ways that are easy to forget today. The discovery of animals once considered mythical, such as the okapi in 1901 or the giant squid confirmed by photography in 2004, proved that gaps in biological knowledge were real, not imagined. A lesser-known detail of early zoological expeditions: many were forced to carry duplicate specimen jars because humidity destroyed preservatives faster than expected. A design compromise of field science that limited how much biological evidence could survive the journey back. The parents of cryptid hunting were not storytellers, but institutions of natural history. Museums, universities, and geographic societies spent the 19th and early 20th centuries mapping animals of remote regions. Reports from missionaries, traders, and surveyors often mention creatures that did not match known species descriptions. A lesser-known fact: during several early expeditions in Central Africa between 1890 and 1910, testing of specimen traps showed that nearly 40% failed because of rusted springs, a test result that forced expeditions to carry multiple mechanical backups. The idea of deliberately seeking unknown animals slowly formed inside that environment of incomplete knowledge. In the early 20th century, explorers occasionally funded searches for rumored creatures, the so-called lost animals of remote regions. The term cryptozoology would not appear until the 1950s, but the behavior that defined it was already taking shape. A lesser-known operational problem emerged in early expeditions: glass photographic plates often shattered during mule transport, a production issue that caused the loss of entire photographic records of fieldwork. At first, the work looked very similar to ordinary wildlife research. Expeditions carried cameras, plaster for track casts, notebooks, and rifles for defense. What changed was the target: animals reported but not proven. The process required patience, measured in months and years rather than days. A lesser-known constraint involved supply chains of plaster powder used for footprint casting. Humidity turned entire shipments into useless blocks during jungle expeditions, a supply constraint that forced many investigators to rely only on sketches. The childhood of cryptid hunting was awkward and uncertain. The mid-20th century produced scattered efforts across several continents, often led by amateurs with enthusiasm but limited training. Reports of creatures such as the Himalayan Yeti, the North American Bigfoot, and the Loch Ness creature attracted attention but rarely produced evidence that satisfied scientific standards. A lesser-known element of field preparation was the training of trackers borrowed from wildlife biology. Students often spent weeks learning recognition of animal tracks by casting hundreds of practice prints in sand pits, a crew training detail that determined whether field evidence would be usable. Early investigations produced many mistakes. Misidentified bear tracks, hoaxes created with carved wooden feet, and photographic illusions filled the early record. The difficulty of separating folklore from biology became the defining challenge of the discipline. A lesser-known adaptation developed among investigators. When plaster was unavailable, some trackers used candle wax poured into prints, a battlefield improvisation of field science that produced fragile but sometimes useful molds. Scientific skepticism grew quickly, and with it came countermeasures. Zoologists insisted on strict rules of evidence: clear photographs, DNA samples, or physical specimens. Without those standards, claims remained outside accepted science. A lesser-known countermeasure appeared in the 1970s. Several universities began quietly testing alleged hair samples with early microscopy techniques. revealing that many unknown samples were actually from bears, dogs, or deer. Despite criticism, interest did not disappear. Instead, it shifted shape. Small groups began organizing systematic searches, borrowing techniques from wildlife biology, mountaineering, and even military reconnaissance. The practice slowly developed a structure resembling a profession. A lesser-known psychological effect appeared during long wilderness searches. Researchers reported that extended isolation increased misinterpretation of ordinary sounds. With wind or animal calls frequently perceived as footsteps, weather and terrain became constant adversaries. Dense forests blocked lines of sight. Mountains scattered sound. Rivers erased tracks within hours. Even experienced trackers could spend weeks searching without finding a single trace of unusual activity. A lesser-known terrain fact: in temperate forests, rainfall of more than 10 millimeters can erase track impressions in less than 4 hours, dramatically reducing the useful window of evidence collection. By the late 20th century, the practice had entered a period of growth. Portable cameras, audio recorders, and night vision devices allowed investigators to observe wilderness areas in ways that were impossible earlier. Expeditions became more systematic and sometimes more ambitious. A lesser-known shift in command doctrine occurred in several organized search groups. Teams began dividing search zones into grid sectors of approximately 1 square kilometer, a method borrowed from search and rescue operations. The system around the work expanded. Equipment suppliers began selling specialized geothermal cameras, motion sensors, and trail cameras designed for wildlife observation. Manuals describing evidence collection techniques circulated among enthusiasts. A lesser-known design compromise of early motion cameras involved battery life. Early models often lasted fewer than 72 hours in cold environments, forcing investigators to choose between coverage area and duration. Standardization followed slowly. Procedures for collecting hair samples, measuring footprints, and recording environmental data became more consistent. Some investigators attempted to document sightings using the same formats employed by wildlife surveys. A lesser-known test result from early thermal cameras showed that dense foliage could reduce detection range by more than 60%, meaning large animals could pass within 30 meters without appearing clearly on screen. The logistics of extended fieldwork grew more complex. Expeditions required transportation, food, communication equipment, and safe navigation in remote environments. Some investigators began working in teams with defined roles: tracker, camera operator, navigator, and data recorder. A lesser-known production issue appeared in the manufacture of trail cameras during the 1990s. Memory storage limits forced many devices to overwrite older images automatically, erasing potential evidence before investigators returned. The peak of public attention arrived during the early 21st century. Television documentaries, online forums, and amateur research groups created a surge of interest. For a brief period, cryptid hunting became visible to millions of viewers. A lesser-known supply constraint of televised expeditions involved night vision batteries. Extended filming often required dozens of replacement battery packs per week in remote locations. At its most dramatic, the work resembled a hybrid of wildlife research and expedition exploration. Teams would establish base camps, deploy cameras, record environmental sounds, and conduct night patrols through forests. Each sound in the darkness demanded evaluation. A lesser-known training detail involved recognition of animal vocalizations. Investigators often studied hundreds of recordings of owls, coyotes, and foxes to avoid mistaking ordinary calls for unknown species. The defining scenario of the peak period often involves a simple moment. A remote camera captured a blurred silhouette. A footprint appeared along a muddy riverbank. An unfamiliar sound echoed through forests at night. Each fragment of evidence triggered weeks or months of analysis. A lesser-known improvisation sometimes used by trackers involves sprinkling flour along suspected trails at night, allowing subtle footprints to appear by morning. What made the practice effective, when it worked at all, was patience. Wildlife biologists know that large animals can move across enormous territories without being seen. Some species remain elusive for decades before confirmation. A lesser countermeasure adopted by skeptical researchers involved DNA barcoding of environmental samples such as water or soil, a method capable of detecting animal presence without direct observation. But the cost of the work was real. Long periods in remote wilderness demanded endurance. Cold, insects, and fatigue wore down even experienced investigators. Many expeditions ended with nothing but notebooks filled with observations. A lesser-known medical effect reported by field teams involved sleep disruption during extended night watchers. Irregular sleep cycles increased error rates in sound identification. Psychological pressure also accumulated. When people spend weeks searching for something rare or uncertain, expectation begins to shape perception. Researchers in sensory psychology describe this effect as confirmation bias. A lesser-known psychological study of wilderness observers found that expectation increased false identification rates of animal sounds by nearly 25%. Physical risk remained constant. Remote terrain meant slow evacuation during injuries. Encounters with known wildlife bears, cougars, or wolves were far more common than encounters with anything unknown. A lesser-known terrain impact involved altitude fatigue. Investigators operating above 2,500 meters often experienced reduced concentration and slower reaction time. As technology advanced, the practice began to change again. Environmental DNA analysis, satellite mapping, and automated wildlife monitoring reduced the need for human patrols. Evidence could be gathered indirectly through sensors and laboratory tests. A lesser-known command doctrine shift appeared in several research organizations. Emphasis moved from direct pursuit to passive monitoring networks of cameras and environmental sampling stations. At the same time, skepticism inside the scientific community remained strong. Despite decades of searching, no clear physical specimen of a large, unknown land animal in North America or Europe has been confirmed. The gap between belief and proof remained wide. A lesser-known countermeasure used by research institutions involved blind testing of submitted samples to prevent bias during analysis. Public fascination slowly cooled. Television programs faded, and many amateur groups dissolved. The work did not disappear, but it returned to smaller circles of enthusiasts and researchers. A lesser-known supply problem emerged for independent investigators. Specialized wildlife cameras became expensive as manufacturers shifted focus toward commercial hunting markets. The practice entered a kind of old age. Technology continued to improve, but expectations changed. Instead of dramatic discoveries, investigators focused on careful documentation of unusual wildlife reports. A lesser-known design compromise of modern wildlife sensors involves sensitivity settings. High sensitivity increases detection of small animals but dramatically increases false triggers from wind-moved vegetation. Even today, occasional reports appear footprints in remote forests, strange sounds recorded at night, brief sightings in mountains or swamps. Most are eventually explained. Some remain unresolved. A lesser-known terrain effect continues to complicate investigation. Thick undergrowth in temperate forests can limit visual detection range to less than 20 meters. The legacy of cryptid hunting is complicated. On one hand, it produced a large archive of wildlife observations and environmental recordings. On the other hand, it demonstrated how isolated hope and expectation can shape interpretation of evidence. A lesser-known doctrine shift within wildlife biology occurred partly because of these investigations. Modern field research now emphasizes strict documentation protocols to prevent misidentification. The tools of the trade left their mark as, motion cameras, environmental DNA sampling, and digital mapping, all technologies used in cryptid searches, became valuable for legitimate wildlife conservation projects. A lesser-known test result from environmental DNA studies showed that a single liter of river water can contain detectable genetic traces of dozens of species. In the end, the life story of hunting cryptids is not really about monsters. It is about the edge of human knowledge, where curiosity pushes into territory that evidence does not always support. The forests remain large, the oceans deeper still, and science moves forward carefully, one verified fact at a time. A quieter lesson remains beneath the adventure. In the wilderness of the world, patience matters more than belief. 412 camera traps once operated simultaneously in a single wildlife survey of the Pacific Northwest during the early 2000s, and not one of them captured an undiscovered large mammal. That number hangs over the next stage of this life story, because the growth of cryptid hunting was never about certainty. It was about the construction of a system, determined to keep searching anyway. Growth rarely begins with excitement. It begins with paperwork, equipment lists, and quiet improvements that outsiders rarely notice. By the late 20th century, the practice of searching for unknown animals had started to resemble organized field research. Small teams learned that wandering randomly through forests produced almost nothing, while structured patrol routes increased the odds of useful observation. A lesser-known design compromise emerged during the development of portable trail cameras in the 1990s. Manufacturers intentionally reduced flash brightness to avoid frightening animals, but the weaker illumination also produced grainier images that complicated later analysis. Equipment slowly standardized. Motion-activated cameras became the backbone of observation networks. A single camera might watch a trail for weeks, silently collecting hundreds of photographs of ordinary wildlife before a human investigator ever returned. A lesser-known test result from early camera deployments showed that animals triggered sensors far more often than expected. One study recorded more than 3,200 activations in a single month, almost all caused by deer. Evidence collection procedures also matured. Investigators learned to photograph footprints with measurement scales, cast tracks using plaster or dental stone, and preserve biological samples in sterile containers. Those small habits mattered more than dramatic moments in the field. A lesser-known production issue appeared in the supply chain of dental casting stone used by field investigators during several winters of the early 2000s. Moisture contamination caused entire batches to cure too slowly, ruining footprint molds. As the system expanded, logistics began to dominate the work. Remote expeditions required transportation, batteries, weatherproof containers, and reliable navigation tools. GPS receivers replaced paper maps in many field teams during the 1990 South. A lesser-known supply constraint of early handheld GPS units involved battery endurance. Some models drained for AA batteries in less than 10 hours of continuous tracking. Training also evolved quietly. New investigators often underestimated the difficulty of distinguishing animal traces. The track of a black bear stepping partly over its own hindprint can resemble a large primate footprint at first glance. A lesser-known training detail from wildlife tracking programs required students to identify at least 50 common animal tracks. Before participating in field surveys, the system matured further. When audio recording entered the field, digital recorders allowed investigators to capture nighttime sounds that human observers might miss. Some hoped that unknown vocalizations could reveal the presence of undiscovered animals. Lesser-known battlefield improvisation of audio teams involved suspending microphones from tree branches to reduce ground vibration noise. Technology created hope, but it also created more data than anyone expected. A week of monitoring in a forest could generate thousands of photographs and hours of sound recordings. Sorting through those files required patience, bordering on obsession. A lesser-known countermeasure developed by experienced researchers involved automated filtering software that eliminated recordings containing only wind noise. Even with better tools, the environment remained unpredictable. Whether erased tracks, flooded rivers, swallowed evidence, snow transformed landscapes overnight. A lesser-known medical effect among long-term field researchers involved cold-related nerve irritation in fingers, caused by repeated handling of wet equipment in freezing temperatures. The peak period of organized cryptid hunting arrived when media attention amplified the work. Television programs followed teams into forests and mountains, documenting night patrols and evidence searches. The audience saw excitement, but rarely the weeks of silence between events. A lesser-known terrain impact during filmed expeditions involved lighting equipment. Bright film lights frequently scared away wildlife before cameras could capture natural behavior. During the peak years, one typical scenario repeated again and again. Investigators would find a set of unusual footprints along a muddy trail or riverbank. Measurements were taken, casts were poured, photographs were recorded. A lesser-known command doctrine shift within several research groups required 2 independent witnesses to confirm measurements before any track was considered credible. Sometimes the evidence appeared convincing. Large footprints measuring more than 35 centimeters occasionally appeared in soft ground. Reports of heavy footsteps in forests during nighttime patrols added tension to the search. A lesser-known design compromise of measurement tools involved collapsible rulers. Their joints sometimes shifted slightly under pressure, producing small but important measurement errors. What made the system function during its peak was persistence. Teams rotated shifts, monitored equipment, and revisited sites repeatedly. Over months, in wildlife research, repeated observation is often the only way to reveal patterns. A lesser-known test result from repeated camera surveys showed that some animals avoided camera traps entirely after the first flash exposure. The cost of maintaining such operations grew quickly. Batteries, transportation fuel, replacement cameras, and data storage required steady funding. Some teams relied on television sponsorship or donations from enthusiasts. A lesser-known production issue affected early infrared cameras. Sensor failures increased sharply in humid climates, sometimes disabling devices within weeks. Human endurance remained the most important resource. Field investigators often spent long nights listening to forests that seemed completely empty. Fatigue slowly changed perception and reaction time. A lesser-known psychological effect recorded among night observers involved auditory pareidolia, the tendency to interpret random noise as meaningful patterns. Injuries also occurred more often than outsiders realized. Slips on wet rocks, insect bites, dehydration, and encounters with ordinary wildlife created constant hazards. A lesser-known terrain factor in dense forests is limited visibility. Investigators sometimes walked within 15 meters of large animals without noticing them. Despite the risks, the work continued because of a single possibility: discovery. Throughout history, animals once dismissed as myths eventually proved real. The mountain gorilla, for example, was described in reports long before science confirmed its existence. A lesser-known doctrine shift in modern zoology encourages investigation of unusual reports, but only under strict evidence standards. Eventually, however, technology changed the rules again. Environmental DNA sampling, often called EDNA, allowed scientists to detect animal genetic traces in soil or water samples. This method could reveal species presence without direct observation. A lesser-known test result from early eDNA experiments showed detection accuracy exceeding 90%. When samples were collected within 24 hours of animal activity, the effect on cryptid hunting was subtle but profound. Instead of searching blindly for large creatures, researchers could test environments for unknown genetic signatures. If none appeared, entire regions could be ruled out quickly. A lesser-known countermeasure used in laboratory analysis. involved multiple contamination controls to prevent human DNA from appearing in wildlife samples. As scientific tools improved, enthusiasm for traditional searches began to fade. Many investigators realized that decades of fieldwork had produced intriguing stories, but little verifiable evidence. A lesser-known supply constraint emerged in independent research. Labor-based analysis of DNA samples often cost hundreds of dollars per test. Gradually, the practice entered a quieter phase. Smaller groups continued fieldwork, but large expeditions became rare. Most modern investigations rely heavily on automated monitoring systems, a lesser-known design compromise. In modern wildlife, sensors involves detection range. Increasing sensitivity often multiplies false triggers caused by falling leaves or rain. Still, reports never disappear completely. A hunter glimpses a large shadow moving through forest. A hiker hears heavy footsteps along a remote trail. The stories circulate and curiosity returns. A lesser-known weather effect complicates such observations. Fog and humidity can distort sound direction, making distant animals seem much closer. Today, the practice survives mostly as a hybrid of amateur investigation and scientific curiosity. It exists at the border between folklore and biology, neither fully accepted nor completely dismissed. The lesser-known command doctrine shift among wildlife researchers encourages documentation of unusual sightings, even when they later prove incorrect. The legacy of cryptid hunting is not a confirmed creature hiding in forests. Instead, it is a body of experience about how humans investigate the unknown. Methods improved, technologies advanced, and skepticism sharpened. A lesser-known test result from long-term camera trap networks shows that continuous monitoring can reveal new behaviors in known animals even when no new species appear. And that may be the quiet truth at the end of this strange biography. The search for cryptids taught investigators something unexpected. Wilderness still contains mysteries, but most of them belong not to monsters, only to animals we have not yet understood.